in chat box. Okay, I think everybody actively participate and ensure, give your assurance that you are present. So now we discuss the next blockchain based public distribution system. Actually, in India, public distribution system facilitates the supply of food grains and distribution of essential commodities to a large number of poor people through a network of fair price shop at subsidized price on a recurring basis. With a network of more than 51,817 lakh fair price shops claiming to distribute annually commodities worth more than 15,000 crore to about 30 crore families. The public distribution system in India is perhaps the largest distribution network of its type in the world. Subsidized ration distribution takes place each month to the ration card holder across the state under public distribution system. Public distribution system involves procurement from the farmer till distribution to ration card beneficiaries, comprising different entities in between, such as central and state agencies, millers, transporters, shop owners, and then finally to the beneficiaries. A major feature of the public distribution system is the general lack of accountability down the entire supply chain, leaving the leakage that occur at different points completely unaccounted. Blockchain technology can be useful in managing supply chain effectively using distribution ledger technology. Entire supply chain starting from procurement till disturbance can be part of blockchain. Now, the process flow, how food grains at subsidized rate provided to the beneficiaries. Initially, farmer cultivates the food grains, which is then procured by the government under minimum support price. Millers identified by the government collected food grains initially and then hull it depending on the commodity to be returned to the government. It is then moved to state godowns to be distributed to various block godowns. From the block godowns, these commodities get distributed to various fair price shops for beneficiary distribution. Government agencies identify and allow the millers to register with them for the purpose. Farmer register with the miller to deposit their produce and collect their payment under minimum supported price. A farmer gets paid under minimum support price based on the quantity supplied. Miller then processes these commodities to make it available at a storage point for further distribution. Miller gets paid for processing these commodities. Miller also gets paid for transporting them to nearest state godowns. Fair price shop owner collect his quota from the storage point to be distributed to the beneficiaries. Use of blockchain can remove at least delay in payment to the farmer based on procurement done by the miller. Since miller is responsible for the collection and stock initially, Unless the transaction is approved by the farmer, miller cannot register the quantity collected. This makes each transaction non-repudiation in nature. Since calculation and payment must happen based on this initial data, data provenance, basically recording history of data, can be sealed using blockchain technology. The decentralized distributed ledger technology makes all the stakeholders refer to their local copy of the ledger to make decisions and act accordingly. Certain activities such as payments to farmer can be done without waiting for the miller to hull them. Since the procurement season is defined for each commodities, payment can start immediately without waiting for the other actors to complete their processes. This makes each transaction as non-time critical and thus eligible to be part of blockchain technology. Since farmer only interact with the government identified miller, it need not be part of a public chain wherein transporter is participating in the network. There are various information related to miller, farmer, storage, and payment related is stored in the blockchain. The current status of proof of concept application for PDS is developed in Python web application with 3 stakeholders, basically users, miller, farmer, and the admin users. The application interacts with the blockchain node and to the relational database management system and is deployed in Docker container. The proof of concept covers the procurement process of public distribution system, which involve the miller registration with the government and the farmer registration with the miller. The registration modules write the registration details to the blockchain as well as to database. The data updating module read the existing data from the blockchain and write back the updated details. I clear one point here, that write back to the update details doesn't mean that violates the blockchain concept. Here update detail means a new block has been created in which modified data is present. The super user modules provide option to read and compare the data from both the databases and the chain, which in turn help to identify any updated anomalies. Any question related to public distribution system, you may please raise. Any participant have any question, any query regarding public distribution system successfully implemented in India? No question from participant side, so I can proceed further. The next case, GST. The Department of Commercial Taxes are actively implementing GST in their respective states. Normally, once a GST registration is obtained, The trail of entire taxpayer transaction of a GSTN is of utmost importance for enforcement, assessment related activities. The vital information such as registrations, amendments, payments, ledgers, annual returns of taxpayer forms the basis for assessment to ascertain that appropriate tax is paid in time and no dues penalty is applicable to taxpayers. All returns filed by taxpayers are normally self-assessed, but the tax enforcement authorities need to ensure that all liable tax is paid to government in time. It is also very important that essential information of taxpayer assessment and order passed is available readily till date to complete an assessment. Any enforcement activities require ready availability of authenticated, immutable record pertaining to the taxpayer. In order to have this essential taxpayer information as authenticated, immutable, tamper-free, blockchain is the only suitable technology through which the desired objective can be achieved. The vital information which is usually needed by tax authority are registration detail, annual returns, payments and ledger details, notice served on taxpayer under various sections of the Central Good Service Tax Act. Other informations like returns, annual returns in GST R9, 9A, 9C, and final return GST R10, taxpayer payments and ledger information which reflect the GST payment status of ledger. It is also necessary to know the refund claim settled for taxpayers, the various show cause notice and order issued under various sections of Central Good Service Tax Act will clearly reflect the nature of enforcement, assessment and prosecution activities initiated by tax authorities. The taxpayer involved in the exports of goods and services are normally granted outright refund provisionally and also avail from tax authorities. A separate tag of such taxpayer information will improve service delivery. E-way bill information on blockchain will help in tracking behavior of GST involved in interstate transportation of goods and services. Right information in a timely manner to the right authorities will bring effectiveness in entire gamut of the GST implementation and enforcement activities, and plugging every gap arising due to unavailability of decision support, ready information, thereby contributing to increase in tax collection, recovery of tax liabilities, penalty, etc. All the above tailor-made data sets need to be maintained in the GST blockchain. Data set schemes will have to be tailor-made for the above areas of activity and are required to be captured in the replicated distributed GST ledger at the very source. This use case is for government. A private permission distributed ledger-based GST blockchain will be required to be built. Now, question arises, why blockchain for GST? As Government of India proposed one nation, one tax. Earlier, there are various kind of taxes are there, and those are luxury tax, entertainment tax, excise, central state tax, value added tax, octroi, local tax, and entry tax. Government of India proposed to eliminate these taxes and implement only one tax, and that is uniformly applicable throughout the India, and it gives name goods and service tax. Blockchain-based GST records will be immutable, tamper-free, as data can be append only, no modification, deletion possible, thereby providing all stockholders, agencies with required information for day-to-day enforcement activities. Stakeholder outside GST ecosystem, such as other government enforcement agencies, etc., can also have access to the blockchain-enabled GST records. As you see, taxpayer, tax authority, and GST practitioners contribute data to blockchain-based system. Blockchain info can provide several views of same information with varying granularity and detail based on the access control defined. Registration, annual returns, payment and ledgers, show cause notice, and orders. Durability, reliability, due to decentralized distributed network, blockchain does not have central point of failure and better able to withstand malicious attack. Greater security make it more reliable. Empowered stakeholders control their transactions and informations. Transaction authorization is through consensus, which makes high availability can be realized with distributed ledger technology. So, enforcement, assessment, demand and recovery, prosecution may be possible, and state tax authorities, central tax authorities, and other tax authorities able to views of information with according to their powers and access control credentials. It is also necessary to know the refund claim settled for the taxpayer. The various show cause notice and order issued under various sections of Central Good State Service Tax Act will clearly reflect the nature of enforcement, assessment, and prosecution activities initiated by tax authorities. The taxpayer involved in the exports of goods and services are normally granted outright refund provisionally and also avail from tax authorities. A separate track of sub-taxpayer information will improve service delivery. Now, stakeholders of GST blockchain systems are State Commercial Tax Department, Central Board of Indirect Taxes and Customs, Enforcement Directorate, Directorate General of Foreign Trade, various other central and state authorities empowered. The benefits with blockchain-based GST are transaction authorities by the tax authorities empowered are written to the GST blockchain. This single trusted source of taxpayer information is used for all further dissemination of information. There is no intermediate authority involved in this process of information access. Dissemination of information is seamless and transparent. Different authorities need different information views with varying granularity. All such information views disseminations can be made available easily. The GST blockchain can act as a reliable source of information for global trade authority to confirm the exporter's business profile in respect of tax payment, letter of undertaking, etc. Now, any question regarding GST based blockchain? You may please unmute yourself and ask. Okay, now no question from participant sides. So we move to the another system successfully implemented by Government of India. That is blood bank. The objective of using blockchain technology in blood bank system is to ensure that the patient gets safe blood. This can be achieved by the different entities in the chain, which verifying the quality, expiry of blood from the blockchain that provide the trust factor that is required. The donor details would also be verified by the collection center to ensure unsafe donors are excluded. As a fallout, all the stakeholders will be able to know the availability of blood in different blood banks. The objectives to implement blockchain in blood bank is to ensure quality of blood can be ascertained by any node of the chain. Donor history can be known to each node. Detail of blood, including expiry of blood in each state, can be verified. Sample to recipient integrity is maintained. Availability of blood with respect to blood banks. In India, 90% of blood donation are carried out in camps set up by various organizations. While all the donated blood goes through the testing phase and safe blood is separated, sometimes unsafe blood can also be penetrate this test and reach the patient, infecting them. To eradicate or to remove this system, give us help to provide better blood or good blood to the recipient. The biggest challenge are setting up a blood repository is donor authentication, identification, and more importantly, donor filtration based on past eligibility record. This makes it important to have a centralized platform for blood donors. The need of blockchain in blood bank. National AIDS Control Organization recently reported that 2,234 patients got infected with HIV cause of bad blood transfusion in the last 16 months. The figure stands at more than 14,000 infections in the last 7 years. In spite of the latest testing methodologies leading to lesser window period of these fatal diseases, the problems are still increasing. One of the key reasons has been the absence of centralized blood donor registry and unique donor identification program. With no centralized blood donor registry in place, blood donors found reactive during their previous donation at a particular blood bank again end up donating at multiple blood donation camps. Also, a lot of under quarantine donors end up donating again. Another challenge in blood cycle management is the gap in demand and supply. On the hand, 30% of the patients don't get the component which they are in need of. And on other hand, 10 to 12% of the components get waste due to expiry. Now, blockchain in blood bank. In this, a digital ledger technology has been implemented, and it provides a single point of truth, a shared tamper evident ledger. Here we use Ethereum based network. Each member has a copy of the same ledger. So asset provenance and traceability are transparent, and trusted blockchain can be applied in a blood bank. The users in blood banks are donor, recipient, hospitals, blood collection centers, and blood testing labs. Hyperledger sawtooth digital ledger is used for building, deploying, and running the entire system. Smart contract abstraction provided by the sawtooth hyperledger. Recording transaction rights from donor registration to hospital and other important properties of blood like group, testing remark, expiry date, temperature, etc. Now, how blockchain based system in blood bank working efficiently. First, donor has been registered. And then sample collection unit collect the blood from the donor and submit the record to the system. Then collected sample sent to the sample test center, and respective information once again updated to the blockchain based blood bank. Once blood has been received at blood bank, then information once again updated on the system. Then when hospital generate a request for a blood, that request sent to blood bank via blood bank based blockchain system. Once blood has been delivered to the hospital, hospital update the same information to the system. So phlebotomist who collect the blood, transporters responsible to deliver the collected blood to the blood bank. So these three act as a actor. And similarly, the administration of blood bank on another side, transporter who collect the blood from the blood bank and send to the administrator of hospital, doctor of the hospital, nurses, and recipient. These act as a actor on the other side. The blood unit production smart contract is used to verify actions from drawing blood until its reception by the blood bank. Whereas on the other hand side, the blood unit consumption smart contract is used to verify action that occurs from requesting blood until its administration to patient. Now the blood unit production and blood unit consumption, they send their information to the centralized IPFS, which act as a distribute ledger management system. Then entire information once again updated on the system, which is based on Ethereum. So this is the system implemented on blood bank. The entities involved are donor, collection center, testing center, blood bank, hospital, Department of Health and Family Welfare. Now, in each entity, there is a system is there. It may connect via internet or peer-to-peer or through VPN. So first donor register himself on the system. Sample collection agency already registered and test center also. Similarly, blood bank and hospital also collected. So the entire information related to a single blood unit is available to all, and it initiated from donor side and ends after the blood received by the recipient. What type of information has been stored? So donor related medical history, age, the location where donor donate the blood, donation center information like its date, when blood has been collected, the type of blood, maybe O group, A group, B group, AB positive, like that. Then transportation. So the agencies who are responsible for transportation of blood from donation center to pathology lab. So the information like driver's name, date of delivery, time, address for delivery, etc. has been stored on database. Then at the pathology lab, temperature, humidity, any complication during test, and date of packaging has been stored on the database. In the blood bank, verifying date, storing date, delivery date to the recipient, the means of transport by which blood sent to the recipient, that kind of information is stored. Regarding recipient, how many units recipient received, when it is received, so date and time, such information stored on the blood bank based blockchain system. So now any question? You may please raise. Now the last is the state excise supply chain. Excise duty is a form of indirect tax that is levied by the central government of India for the production, sale, or license of certain goods. Excise duty charges are also collected by state government for alcohols and narcotics. The customer does not pay excise duty directly to the authorities, but it is added to the cost of the product by the producer or merchant and then passed on to the consumer by way of increased price. In India, the Excise Duty Act 1944 governs the regulation related to excise duty in India, and the tax is administered by both Central Board of Excise and Custom. Now question arises, why should pay excise duty? Let us consider the fact that excise duty is charged on the manufacturer or production of good. The producer manufacturer of the good is liable to pay excise duty to the government. The three parties that must pay excise duty that are the individual or entity that manufacture or produce a good. Second, the individuals or entity that was responsible for the manufacture of goods by way of hiring labor. And the third and the last one, the individual or entity responsible for the manufacture of goods by other parties. State excise provide 20% of the share of the government's own revenue in most states. To augment the excise revenue, it is needed to ensure that all beverage alcohol, medicinal alcohol, industrial alcohol, and life-saving narcotics drugs available in the states are sourced and sold through legal channel, and has to eradicate manufacturer, distribution, supply, and sale of illicit, distilled, counterfeit, non-duty paid intoxicant to arrest revenue leakage point and safeguard public health. Most excise supply chain systems are centralized systems that enable to capture production data, provide with shopping cart facility, generate transport pass, and invoice during supply, maintains inventory on real-time basis, integrates with bank payment gateway, maintain pay wallet involved of third parties, includes bank, police, excise authority, all of whom process and verify transaction as they pass between buyers and sellers before authorizing the transfer of value, whether packaged liquor or invoice amount or service like NOC or pass. So stages in the supply chain include packaged liquor manufacturing bottling plants, both country liquor or foreign liquor. Produce bottled liquor affixes with 2D QR code hologram label on the bottle tops. Put the bottle in a case, affixes case level QR code, is stored in adjunct bonded warehouse. Now, item is created by manufacturer or bottling plant. Then item is packaged by affixes 2-dimension QR code hologram label on the bottle top. Packet has been labeled by put the bottle in a case, affixes case level QR code. stored in agent bonded warehouse. Traders, distributors put requisition for procurement of packaged liquid from manufacturing or bottling plant. Now API generates blockchain transactions that has been scanned with app. Requisition, receipt, payment of excise, then scanned using handheld terminals, debit and credit opportunity operations in digital inventories, then again API generates blockchain transactions which is scanned by the retailers. Retailer scan the packet and give their acceptance. Once retailer accept, its API generates blockchain transaction for sale. Consumer use their app to scan the packet, and finally entire transaction has been stored in a blockchain based state excise. To implement this, various challenges are there. The first one is excise revenue is being losing out because of a significant increase in sale of fake labels, poor quality blends that are packaged as popular premium alcohol brands. It has become increasingly lucrative to sell counterfeit label because of a sharp rise in excise duty. Sales of non-duty paid fake bottles products are now accounting for as much as 10 to 12% of overall excise revenue. It is very difficult to ensure authenticity of packaged liquor that is required for arresting revenue leakage and safeguard public health. Even if there is a central repository that store all the information about the supply chain of packaged liquid from manufacturing till retailer outlet, it is difficult to establish trust among all the entities involved. The fundamental issue is that central repository does not have the ability to provide decentralized trust, immutability, and tamper evidence. Stakeholders cannot maintain an appropriate overview of their supply chain network. Within a state excise supply chain, data is fragmented into various data silos where very little data interoperability exists. In other words, there is a high information asymmetry. The stakeholders, example, government, packaged liquor manufacturing, warehouse, retail outlets, and consumers have no incentives to share data. This makes it harder to ensure integrity of packaged liquor as they flow through the supply chain. As a result, many people lose their lives due to consumption of spurious alcohol. Fighting contamination, reducing counterfeiting, and maintaining an efficient supply chain are other challenges. Consumers are demanding even higher level of transparency for health hazards protection and ensuring quality of alcoholic beverages. In proposed environment of state excise supply chain management system enabled by blockchain technology, transaction will become peer-to-peer with little need for intermediate fees. At every stage, the movement of goods, the detail of the movement along with the necessary permission detail reproduced in the movement documents would be stored in the chain. Especially the lot number, the date of receipt, quantity, etc. can be recorded. The process of verification of the details of the goods received as indicated in the movement document can be verified with that in the blockchain. QR code affixed to the bottle receipt would be compared to that stored as a transaction at the previous level in the supply chain and can be verified. This would facilitate the detection of any tampering of the document and as also the entry of spurious liquor. At the package liquor manufacturing bottling plant, bottle IDs, the case ID that are sent to the adjacent bonded warehouse for storage has to be recorded. When distributor put requisition for procurement of packaged liquor from manufacturing bottling plant, the detail of the payment of appropriate excise duty is stored in the ledger. During the scanning of the QR coded label while uploading into carrier vehicle, the transport pass and invoices are generated. The transport pass and invoice details along with the item-wise ID will be stored in the blockchain. As part of the smart contract execution, debit and credit operations in blockchain will be automatically initiated. Traders, distributors receive physical stock using handheld tracker on arrival of vehicle at their premises. The verification of the supply stock can be ensured by comparing it with the data entered by the distributor and will give the necessary confidence to the distributor about the authenticity. When retailer liquor on shop apply for procurement of packaged liquor from distributor, the data of the invoice ID of the case, etc., will be stored as in the stage when distributor put in request from manufacturing. Let's me take an example of supply chain and liquor history. We observe first of all import permits for raw material regarding the type of material and its quantity may be uploaded on blockchain-based network. The information regarding the means of transport used. Secondly, we store the information related to the tank and quantity as well as raw material for each tank during lab blending process. In the third stage, raw materials and quantity blended, its batch number, date of manufacturing or modeling is slow as when it moved to the bottling plant for packaging in the bottling plant. Once again, QR code label having batch number, lot number has been mentioned, and that information once again updated on blockchain. Then in the warehouse, where these bottles, when requests from buyer receive local permits, other state permit and overseas permit has been applicable, that information may also update on the network based on blockchain. And once I will invoice has been generated, then material has been dispatched with handheld terminal before leaving the warehouse. And when material delivered to the consumer, that information also updated on the blockchain based network. Now, the benefits of implementing blockchain on excise duty. The first one is efficient collaboration between all participants. With this, use of blockchain should help to cut acquisition, management, documentation, and compliance costs. With the ever changing rules, the compliance would be similar. There should be lesser dispute as the contracts can be effectively implemented. Next, improve customer satisfaction. By simplifying the use and increasing transparency, it will also help to improve customer satisfaction. Authenticity of the package of alcohol can be verified by the customer, who would also be able to obtain all the details from the manufacturer to the retail store. Next, process of reconciliation is simplified. There would be any need for each of the stakeholders to perform verification manually and financial transaction detail with the physical records. And every entity will be able to verify the same from the ledger. It would also reduce the risk of human errors. Ability to take informed and timely decisions. Blockchain would ensure continuous availability and accessibility to verify the data associated with packaged liquor supply chain. In case of any fraud, it would be possible to easily identify the complete lot and its location, and the same can be withdrawn in the shortest possible time. Automated reconciliation and payment. In the retailer-supply relationship, the facility exists for cascading purchase order, invoices, receipts, shipping notification, inventory data, and other trade-related documents to not only be automatically matched and verified, but to also trigger payments, replenishments, order, aggregation and disaggregation events automatically based on the codified rules within a smart contract. Recalling of specific cases or log. If a complaint is received regarding the quality, safety of a particular bottle of liquor, then it is recorded in the system. The smart contract can be identify the source of the supply and block the further movement of the commodity till the issues are resolved. Entire course or this session has been refer the chainanalysis.com, blockchain.gov.in, cryptopolitical, and cbsc.certchain.nic and dlkkarnataka.nic.in. So myself, Neeraj Gupta. If you now this presentation, my two subordinates, Matam Naga Naveen Kumar and Karthike Kandukuri, also give their contribution for preparing this material related to blockchain. Thanks to all of you. Now I open the session for query and doubts. If any participant, you may please unmute yourself and raise your doubt. I request to all participants, if you have any doubt, you may please raise your doubt. Sir, regarding the cost, it is a government projects. All these, the case I have taken, all these are government based. So actual cost of implementation is not yet evaluated. And I practically demonstrate you. If you have nobody have any query or doubt, then we will move to the practical demonstration of blockchain, how hash has been calculated, how nonce has been generated, how miners mines. So a little demonstration on blockchain. And now we browse the contents. Sir, in the public distribution system and the blood bank are on public domain, and state excise and Goa GST, these two are on the private network. All are web-based, all applications based on blockchain are web-based, and wallet concept are coming only when virtual cryptocurrency is there. So the cases which I discuss today, cryptocurrency, no such cryptocurrency cases there. So the case of wallet is not considerable here. The payment of farmer is directly go to their the registered bank account. In India, if any benefits from government, that may directly go to their the account of the beneficiary. No mediator is involved for handling and delivering the cash in cash. If any other participants have any doubt, you may please raise, else we now move to practical demonstration of blockchain. Okay, no query regarding the adoption of blockchain in India. So thanks to all of you. Now we move towards the practical demonstration of.
Hello, Neeraj, sir, before you continue, I have a small query.
Yeah.
As to what I've understood so far is, whenever there is a transaction being made, the charges were actually done in the form of gas charges, gas payment through either Ethereum or some kind through wallet. We have MetaMask, for example, and so on. But if it is a government initiated project, like for example, blood bank. So when the blockchain information in the blockchain is being accessed, and when the chains are being created, when transactions are being made, who does the payment for that, and how does the payment happen?
Actually, in India, any services offered by Government of India, all are free of cost. If you go for health services, And if you go for public distribution system, no transaction, no cash involvement, no currency involvement is there. Everything is free of cost. So actually, the implementation of blockchain on blood bank, that is related to the government sector, not for the private blood banks. Similarly, in case of PDS, so this is the entire system is of the government. As in the pandemic COVID-19 period, government, state government as well as central government both provided free ration to all the resident of India. So there is no money involvement is there. And beside the ration, Government of India also provide 5,000 rupees to the below poverty line people. So cash handling is not there. If you have a bank account, you directly get the benefits. Means the mediators or the officers, they have just to validate that the resident belongs to India, and the documents are verified. Once documents are verified, automatically the amount has been transferred from the Prime Minister Relief Fund or the State Chief Minister Relief Fund or other PM Cares Fund. It may directly transfer.
So my question is based on the charges that is there for the transaction in the blockchain. I mean, not for the commodities or for the distribution of the goods, but as to what I have, gone through is whenever we do transactions on the blockchain, there are some costs being incurred. So the cost of doing the transactions on the blockchain.
Okay. Actually, mining charges and validation charges.
Yes.
Are only involved when we go for cryptocurrencies, purchase and sale, and that is in the open market. So suppose you want bitcoins, you want ether, ETH. Now the ETH, which ETH? ETH 1.0 or ETH 2.0? So which ETH? And the second thing is that how many blocks are already present. If number of blocks are increased, means complexity has been increased. How complexity has been increased? If that I have practically demonstrate you, if number of zeros in hash has been increased, complexity has increased, means more energy has been consumed. So they got the more transaction charges as involved. Initially, when miners are working for mining the coins or create the coins, they got better rewards. They got around $2,500 for each mine. But now today they got only $21.5 because every year the mining reward has been just half. Every year it becomes half. So now mining is not the profitable business in the current scenario. And mostly many cryptocurrencies comes into picture and they become fake. The reason is that the miners not get so much reward that is fruitful, because for mining a lot of computing devices are required, which are very costly. So they're not able to maintain at a very low cost. So you see that thousands of cryptocurrencies are available in the market, but only few currencies successfully are in the market. And the reason is that they are develop their product very early. Bitcoin is successful. Ethereum network is successful because smart contract concept they can put up in front of others. But regarding the currency, only Binance, Cardano, and ETH and ETC, two country currencies are there, and Bitcoin. But most prominent currency is still Bitcoin is there, and many currencies failed. Altcoin is coming, safety security tokens are coming, but they failed. The reason is that the number of involvements of basically miners and validators are less, because once a number of validators are not increased, then anyone can capture the computing power more than 51%. When anyone able to capture the more than 51% processing, means system becomes hacked, right? And now you learn more about during the practical demonstration, then you understand very well, right? So there is
Thank you, sir.
yeah, so I try to just demonstrate you, then you understand more. Concept has been clear. So in the screen you have seen that there is a one input in which some data is there, and I'm not typing anything, and still hash has been generated. You have seen that there is a hash E3B0. Am I right? Is it visible to all? Yeah, please confirm. Okay. So now I am typing a small, and you see I am simply typing capital N, and you see that the hash has been changed. Every character, when I enter, you see that the hash has been changed. And it is hash calculation is in real time. And this is possible because the server in which that hashing calculation is done, it is very fast, right? So you see that the entire content has been, the entire hash, the calculation of hash is changed with every character, right? Now I remove it, and you see that again same hash has come in. Sorry for disturbance, there is an urgent call. So you observe that for each sentence, for each data, there is a unique hash. So for blank, again, there is a hash. Now next, I am entering A again, and you see that once again, same hash has been calculated for data A. Now I'm typing D, once again, same data. Now I once again type advanced level telecom training center, again the previous hash of advanced level telecom training center, and now has been same because data there is no change, and you see that the length of the hash is also same. Right? So here some encryption or some algorithms are used. So which algorithm is used? Algorithm used for calculating the hash right now is SHA-256. Yes, and SHA stands for secure hashing algorithm, and it is one way. It is not two way. Once you calculate the hash, and if you are using that hash, you're not able to get the data. If you got the hash value, suppose I am providing you this one 8A C8A C824 up to ED669C, you're not able to calculate that the mean of advanced level telecom training center. It is a one way. In other cryptography algorithms like RSA, DES, EAS, you able to get it. Means chiffering is there and deciphering is there. But here, only single one-way communication is there, right? Now, we move to block. This is a first block, or we can say it is a genesis block. This is a starting of a block. Now, what is the difference between a hash? Here we are calculating the hash value, right? But in the block, you observe here in the hash value that it is prefixed with 4 zeros, right? And I am typing here same thing, right? Now hash is not calculated. Block 1, this is the initial block, and there is some salt value you can say, and that is 72608. So we are calculating the values of advanced level telecom training center in the hash. You see the value of the advanced level telecom training center is 8AC88, right? Now when I move to the block, this is blockchain concept. Blockchain is not a currency. Blockchain is not a crypto coin. It is a concept. So in a blockchain, I wish to create a block. So how block has been created? So in a block, there is a nonce is there is a timestamp is there, and there is some useful information is there. And on the basis of that, I calculate the hash value using crypto algorithm SHA-256, SHA-256. Now I'm copying the same content, advanced level telecom training center, and you see here that hash value is different. The reason is that this hash value has been calculated with nonce and data. So actually, your data is advanced level telecom training center, but in the block 72608, date as well as time is also involved. Here, date and time is not involved. Now, what is the role of miner? Miner mine to calculate the hash value in such a way that the first 4 value initial values of the hash is 4 zeros. Here the first 4 values are 8199. Now I am mining in such a way that hash values come, and now which value has changed? Nonce value has changed. Now I mine it. It takes some time. I set this for 4 initial zeros, so it takes less time. Now you see, my data is not changed. My hash is changed. And what I got? I got 4 zeros initial. So in a blockchain, what we did, we decided how many zeros initially. 2 zeros, 3 zeros, 4 zeros, 6 zeros. That I have decided, and that number of zeros decided the complexity of the calculation. And that much calculation, that much complexity is there. Number of charges of validation, charges of mining, or in terms of gas in case of Ethereum. Actually, gas concept, or basically the transaction fees or the entry fees, is only for Ethereum, not for Bitcoin, right? So here you see that 191599 has been there. Now I simply add S. It calculates the hash value, right? Advanced level telecom training centers, it has a value Now I change the nonce value. I give nothing, right? And I replace it. Now you see, it's the same. Now I mine it. When I mine it, what miners do? Miners use some algorithms, and their main aim is to find the hash value which has 4 zeros, 5 zeros, 6 zeros, 7 zeros. If when number of zeros has been increased, means complexity has been increased, right? Again, I calculate it. Advanced level telecom training center, nonce is same as previously calculated. So this way we are created a Genesis block. Once Genesis block has been created, now you want to buy or purchase crypto coins, or you have to generate some information, right? Suppose you have to implement painting. So painting is JPG, MPG, JPG, PNG, GIF, or any kind of image format or video. So that information once again available in binary format, so that we can post it here and we can calculate the hash. Now here we see the demonstration of block. Now we go for chain, blockchain. Means 2, 3, 4, 5 blocks has been chained together. Now how that I see. So previous hash, because this is the first block, is a Genesis block. So I am not giving any previous hashes there. So I can taken into account 0, all zeros, right? Now I am putting the same value, advanced level telecom training center, right? And I am also giving 0 nonce, right? I'm not giving any nonce, right? So in blockchain, nonce is there, data is there, previous hash is there. On the basis of that, I am calculating the hash. Now I allow, or I inform the miners that such transaction is coming. Now I click here. And what you get once again, you see there is a pattern, 4 zeros are there. Nonce value is 8068678. Means number of iterations have been performed, and at 80,678, when I give the algorithm the value nonce, or you can say adjustment value, so that the previous hash value is 0 in case of Genesis or the first block, and I'm giving the value advanced level training center, first block 80678 is a nonce value, and hash value has been calculated presiding or prefixed with 4 zeros, right? Now I move to the second block, right? Once again I paste it, advanced level telecom center. So basically we are map this situation with the CBSE certificate chain. So let me consider that the first block is a 10th certificate, right? And 12th certificate has been generated now. Advanced level telecom training center 12, right? Or confusion has been removed if I paste CBSE 10, right? Now once again I mine it. When I mine it, 4 zeros are there. Now Control V, instead of 12, or if I give 10, there is a possibility in India that you give 2 10 exams in different years. Means in 2021 you give 10th exams, but you are not satisfied with your marks, and you once again reappear on the 10th examination. So you again go for 10th exam. So you observe that the previous the Genesis block hash 4 times 0971 1BA is now passed to the second block, right? I remove the nonce value. I give the same data. 7 means I wish to reappear on the CBSE 10th board. Previous hash value has come in, right? And this block is specifically for Neeraj Gupta, not for Neeraj Gupta others, right? And second block has been created and I mine it. What you observe? Previous value passed to the next block. Nonce value in such a way that the current block hash value is once again 8028 prefix with 40, right? Now, instead of this, I pass 12. Again, I mine it. And you see that the color has been changed. Now it becomes green, means it is validated by the miners, right? CBSE 12. Now again, hash value has been calculated with prefix 4 zeros. Now I go for BSC, right? Again, hash value has been calculated. You see that, observe here. When I change something, hash value immediately calculated. But the thing is that I want that the hash value is prefixed with 4 zeros. For that, I inform the miners to mine in such a way that with these values, hash value must be in such a way that it is prefixed with 4 zeros. Now miners mine it. And you observe that it is validated. So 10th, 12th, and BSC. Right? So this way, when CBSE certificate chain has been implemented now, and when you want to make a verification, you enter such information and you got the same hash value. That hash value validate that the credentials you have supplied is okay. Now I go for MSC, mine it, and again you observe that 4 zeros are there, and you observe that here the hash value is different in every case. This way blockchain has been implemented, and instead of this, suppose somebody tried to tamper the second block. In the CBSE 12th record, I want to tamper, right? So I make it _1. What happens? If I try to tamper the previous block, block 3, block 4, onwards, all are tampered. If it is possible, if maybe because of any reason, or if you got 51% computing power, you try to tamper the second block, third, fourth, fifth, and onwards, all are tampered. Means entire record has been tampered, right? So this is not possible, right? If I try to tamper, right, I mine it. It validated by one node, but other nodes have record. Other nodes have not such records. They have different records. So this proves that blockchain is secure. Right? Now we come to DLT, distributed ledger technology. In distributed ledger technology, there are different tiers are there. Tier A, Tier B, and Tier C. Right? So for each piece of information I have passed. And mine it. Now what you observe? All are same. So let me take an example of PDS system. So the first block, farmer sell their crop to the government. This block belongs to the farmer. Then second blocks to the miller. Right? So these three pairs are there, and all, if they are, their records are not matched, means informations are not valid. You can change the information till validation, till before validation. Once validation has occurred, you're not able to make any changes. Now, in case of token, you're talking about the cryptocurrency, right? So transactions are there from Darcy, Elizabeth, Begum, Lady Cat, Charlie, right? Suppose you want to make transactions, and these are the records. And what do you want? Suppose you want to make a Neeraj, right? And you see that the transaction has been disturbed. Now I mine it, and instead of $25, I make it 20. Now I mine it. It takes time, means more complexity has occurred, and the amount of time taken by to mine the things, that is based for transaction fees, right? And it is not necessary that transaction fees is same or variable. In some cryptocurrencies, irrespective of the amount, per mining cost is same. In some cryptocurrencies, it may vary, right? So once block has been validated, now we go to the next, and you observe that here 003EA860, that has been passed to the second block. Right? Now I am writing here from Neeraj to Darcy. How much? $20. Earlier $20. Jitna the amount which I have taken from Darcy, I return back, right? But hash value has changed. So every time record, maybe record same or maybe record differ, hash has been unique in nature. Yet date and time is not involved in this demonstration, but it is always unique, as you observe here. Now we come to the Coinbase. In the Coinbase, again, this is a peer A, peer B, peer C. So as many users are there, that much peers are there. So what do you want? I want to pay say $10 to Neeraj. Hash value has been changed, but it is not prefixed with 4 zeros. And nonce are in such a way that you got prefixed with 4 zeros. Mine it. Now you got. And that value has been passed to the next one. So chances of hacking, tampering is not possible in blockchain. It is possible if you got more than 51% computing power. But when you are working in the open platform, it is very difficult to make 51% computing power in your favor, right? Now, this is our website of Government of India, where you got the information about the blockchain. Here, this is the website of CBSE, where it implement academic blockchain document. For verification, you may simply select the class, roll number, date of birth, year, exam type, main exam, compartment exam, student name, and then you click go. If your verified document, if you appear on the CBSE, that you may got, right? And one more thing. This is the Government of India website. Different projects already implemented, that are BSc certificate chain, drug logistics supply chain, certificate chain, public distribution system, blood bank, Goa GST, Goa G Excise, and state excise supply management, e-Abkari name, and blockchain as a services. In the cloud, mostly three domains are more popular, like infrastructure as a services, platform as a services, and software as a services, and backup as a services, and many more. So Government of India launched a new indigenous product in the name of blockchain as a services, right? So this is little bit about blockchain. Now, any question from your side, you may please. Kindly unmute yourself and raise your query and doubt.
Any query? Please ask. Very nice presentation with practical by Neeraj sir. And any query, please ask. Then we can close the session. Mohan sir. Okay. Today I circulate email one link regarding your evaluation session. So request to you, all of you, please fill up timely, and it will be help to complete this training on time. Okay. Or any doubt, any question, you can ask me through WhatsApp or mail back also, no problem. Okay. So today, very nice presentation by the team Iran, Thailand. Then after a good session delivered by the Neeraj sir. So hopefully all are enjoying, and recording session will be shared in the group. So thank for joining today. See you all of you again tomorrow. Have a nice day. Thank you. Namaste.